Everyone, this is lecture 41. Last time we got a problem when we run the system, right? I tried to fix the bug. I think maybe the bug is here. I guess the bug is here because maybe this line has some errors. I guess because the subscriber cannot receive the data after its subscription. So however, that no problem at this line. I think I just stopped that last class temporarily because I want maybe the I think because the problem I think maybe some underlying system has some problems, so I have to stop the class. Actually, it is not. Let us take a look at the end project, and let us try to fix the bug in. I found the bug here. Okay, you can see here the build file. I forget to change the build file. That's a problem. I'm sorry for that. So I mean, when we program with GRID-free, when we program any distributed system with GRID-free, the entire procedure is straightforward. We just use the homogeneous code level design pattern. So that's why I can program the system online, and the system is complete, right? It's impossible for us to do that using traditional any programming languages. So okay, so that's a problem. So if we got problems, even I got problems, those problems or errors, those problems or errors are trivial, should be trivial. And I think I cannot guarantee there are no any problems in the underlying code, because I still trying to improve the quality of GRID-free. Even the distributed primitive APIs and the design patterns must have some problems. I still try to improve it, improve all the fundamental system. But I think if you program some system that is not so complicated, if the system is popular, or the system is running in a mature computing environment, at this version of GRID-free, the current version of GRID-free should be fine. Okay, the bugs, even some bugs exist. I think the bugs cannot be discovered in some the current popular and mature computing environment. Maybe in some company system, for example, the heterogeneous distributed computing environment over the internet, or maybe the human influenced computing environment, maybe we have some problems. But in this case, I don't think so. Okay. So we just so this problem is stupid, right? Okay, we need to change the code. They change the build file subscriber. Okay, I think that's the. Let me check. Subscriber, right? Yeah, that's the subscriber. Okay, so after that, let us run such a system again. Okay, so first we need to log into the remote server. Okay, start the registry server. Okay, move it out to another screen. Then we can start we need to start the one child. Okay. One child is starting. Now we can start another one from here. Okay, to save space, I want to move it out to another screen, and let us open more child. Okay, this is a third child is started. Okay, move it out. The fourth one. Okay, this is the fourth one. Alright, let me see whether we have some other. Now I need to start the root. We need to follow the order I list in the slides, in the previous class slides. You need to follow the steps exactly. If you change the order to start such a system, it's possible for you to get exceptions or errors. Okay, now we can start the PubSub server. Okay, PubSub server is starting. Okay. What else? What else we can do? And okay, we can start. Oh, another problem I encounter, I need to tell you. Maybe, okay. The PubSub server, the publisher, I fixed one bug offline. So usually I do not do that, but this time when I try to run such a system to detect the bug I encountered in last classes, I found one problem here. Maybe this line. Okay, you need to add string this line. Maybe I forgot this line in the previous classes. Okay, so we need to add a string to the PubSub server. So now the code is updated. I remember that's one problem. We forget to do that, but I think this is because it's a typo error. I make a copy paste. Maybe this line is right, just this line, the same code, right? And forget to publish or register the stream on the PubSub server. Okay, now let us PubSub server. So first time, let us run. This is the false text message, right? Text message. I use UJ. We do that before, right? I think it should. Okay, let's run it. Okay, so now the stream. Okay, we got the stream, right? Okay, this stream is existed in the streaming framework. So now I start the subscriber. Okay. Okay, this is the stream existed in streaming framework. Let us take try. Okay, stream is opt-in, right? Receive. Because last time we run a wrong code. We run the subscriber in another project, not this class. So we run a wrong program. That's why we cannot receive the data. Okay, for this time we can maybe we can start another here another subscriber. Let us start another subscriber and try that again. Okay, maybe news portal and subscriber. Okay, now 2 subscribers. Maybe if the let us try this one. Both of them. Now only one unique stream existing inside the system, right? So the broadcasting should be existed between this child and the 2 subscribers. Okay. Okay, now we got both of them get the same data of the stream. So let us, because multiple data sources exist in such a system, so let us before that maybe we can try to run the client, one of the client. Okay, we have 2 types of client. One is receive the message, right? It's the message or the text message. Another one is receive the video data. So this client is receive the text message. Okay. Publisher J. News. Now it can send a query or send a query because both of the 2 subscribers have the same data. So one of them, only one of them, interact with this client. Okay, search request is sent to this subscriber. This one does not receive the message, right? This is a search result. Okay, maybe we can use another one. Okay, get response for the search request. This one cannot. This one is not selected to interact with this client, so no request, no query is sent to this subscriber. Okay, so this is this demo. Until now, this demo is the same. It's the same as what we saw in the previous, almost exactly the same as what we have say in the streaming framework. So now let us stop such a system. Maybe we can use no, maybe for this time we can start the pub sub. We use another one. We have multiple data sources, right? So for this time we still use another text message. The publisher may be the let me try take a look at the options. The options. Okay, maybe we use N. N is the news feed. Okay. Feed. Just use feed. Okay, now two data sources, more data sources are available. One, right? One is newsfeed, another is journalist news. So if so, we can try this one. Okay, now two stream existed in such a system. So a new tab N and feed. Okay, so this subscriber get news feed from this publisher, and this subscriber get news from journalist, right? This is news feed. This is the news from the journalist, right? Okay, no problem. And let us try show another demo. We open the client again. I need to show it. This is another child. This child is responsible broadcasting the news feed, right? News feed notification. This one is I remove it to another window in another screen. Okay, enter a client. Okay, maybe this one is N feed. Okay, this subscriber should receive request from this client, right? Let us take try. Okay, search request is received, right? You can see, right? Search request is there. This one cannot receive any request, search request at this time. Okay. Let us continue. Okay, this demo is fine. Let us continue again. Okay, some newsfeed is available. Okay, this demo is great. And what else we can do? Now we need to check. We have two more text news message, right, for this news stream. If you are interested, you can open more terminals. The comment microblogger, you still can get data, right? Still can get open some subscriber, open the data sources, and open the publisher, so you can access other data sources from the client. Such a system is such streaming framework It's scalable, the scale can be enlarged, it's a resilient system, right? So now we still have one more task we need to do, because we need to, we have a video publisher. This is the last one we need to test. I think until now we didn't got we haven't got any severe bugs, right? The system we got some problem, but the problem is trivial, right? It's just all the problems exist in upper level. We just the problem is caused by our typo errors. Maybe we do not pay much attention to the details. So, but no underlying problem existed, and such a system is we can create such a system in a straightforward manner, right? So now let us take another run another demo for the video. Let us try and take a look whether we have problems or not for this demo. V, right? V represents the video publisher, and the video. Okay, you can say the video is transmitted, radio is transmitted. This child is busy because this child is selected to transmit both the news feed and the video piece. So this child is busy because the child is selected based on the string distance. So because now we only have four children, so it's possible for one of the children are selected more than one times. However, some others are idle. You can see idle, right? These two children are idle because that's the number of children is too small, only 4. But if the scale is large, and if the data source is large, and the data should be distributed evenly in such a system, right? Evenly. So now let us open another. Maybe we can change this one. Okay, video. So this one start to resave. Video. Okay, video piece is received. That's great. It's successful, right? So after the video piece is received, I'm not sure we remember the code or not. The data should be persistent. Data should be persistent on the disk. Let me try. Okay, you can see the data is persistent on the disk. Okay, let us try. Take a look whether the data is there or not. R underscore bake. Bake means back up. Dot. Okay, let us take a look at the code. Whether the file is there or not. Okay. Oh no, we need to log into the remote server. Sorry. Okay, you can see the data is this one is data is received, right? Data received. You can see the size of the data is always increased, right? Okay, that's great. So there is another file. We can remove this file. It's not useful. Okay. Another file will be, you can check that should be accessed by the client. It's persisted by the client. Okay, I try to run such a system when I fix the bug. So you can see, this file is, you can see the user back up the data. So I try to run this system. Usually I try to run such a system online, but because last time we encounter a problem, try to fix the bug. I think maybe the bug is severe. I have to terminate the class because I do not waste your time. However, the bug is still trivial, right? The bug is still trivial. So during the procedure, I run such a system. You can see we got another because I try to run such a system. But you can see the code. I do not change the code. You can follow the code exactly we program online. So that's for this demo. Maybe if so, in terms of the this issue, I think this demo is not so successfully. Okay, but it's good. It's good enough. Okay, now let us open another client. The user, right? User want to access the stream. Access stream. Okay, let us run. Oh, not if we want to access stream, we should use the video client. The code a little bit different from the client that access the message stream, because the data need to persistent. The way video. Okay, we need search query. Let me ensure that for the video client, the access, we need to input the query. The query is a little bit different. Let me check what query we can use. It should be video piece, right? Because it's a message. When the data is sent to the server, we use data is sent. Let me try. I forget which query we can search. Which query we can use to search the data. Okay. Oh, not here. The database. Okay, the video piece is saved here. The message, we can search with this message. Okay, let us take a look at the message. What is a message is? The message is generated in this way. Video publisher is here, right? So okay, this is the message. So we need to search using this query, piece head plus the index. Okay, so this query is usually this query should be generated by the machine. So because we try to be one, right? because we have no enough time to do that, because the system try to download the data. Okay, let us try. Okay, the query is sent here, right? Search query. Okay, you can see, right? Search query is sent here. Okay, you can system data is downloaded. It being downloaded. Okay, you can see, right? Data here. The size is increased, right? Size is increased. Okay, I think until now, the demo system almost finished. Now we need to terminate such a system. We just need to terminate such a system. If the termination is good enough, if the termination is can be done properly, such a streaming framework, such application for streaming work should be successful, right? So you can say this system is complicated. However, I programmed this system online using about 4 lectures, but the effort is more than what I have done before. But the code structure is exactly the same, and we just follow the same code design pattern, code level design pattern to program the entire system. So it's straightforward. It's the old errors we encountered is trivial. So I think this demo can provide you another evidence that GridFree is convenient and convenient and approach to program a distributed system, even though distributed system is already complete, right? Okay, now let us stop such a system. Okay, because it's downloading just and this we need to stop the calendar first. We do not need the code. Okay, now what we can do is stop this one. We stop subscriber. Oh no, publisher first. You need to follow the order to stop such a system. We missed how to start the system, how to stop system. We need to follow the order, right? Exactly. Okay, the publisher for video is stopped. Okay, and we have 3 publisher. So you can see on this is the one of the child. The child only receive new stream because the video is stopped. Video publisher is stopped. Okay, now let us because I just use Ctrl+C to stop publisher. But okay, I mentioned that before. Okay. So now this child is idle because any data is required for it to broadcast. Okay, we can stop this one as well. This is the last publisher, right? Ctrl+C, okay. So we can stop this subscriber. Stop this subscriber. Okay, this is one of the child. Okay, now we need to stop the child. All the children need to be stopped. Okay. Okay. Children stopped. 4 children. All the children are stopped. That's great. And this we can stop the root at this time. Okay, that's great. This is a PubSub server. Great. And the last one is a register server. Okay. Okay, now the streaming framework, the news portal established on the streaming framework is finished. It takes us at least 6 lectures. It's a large project, and I need to emphasize again our system. If you program such a complex system using GridFree, the procedure is straightforward, and you just repeat some coding effort according to the existing code level, design patterns. I think even though such a system is complicated, you can do that. I can do that online. I think usually no one can, at least according to the best of my knowledge, no one can do such work, such a complicated work online. So I think the video can prove the most important feature of GridFree. It's highly patterned, distributed framework. Okay, it's convenient for you to program with distributed primitives. Distributed primitives is so important to support a generic and self-contained distributed programming paradigm. Okay, that's another evidence for this conclusion. Okay, if you have any questions, just let me know. Okay, next time I will talk about I will create another application. It's called e-commerce portal. It's another challenge for us, right? I will try to create most popular distributed framework using GridFree online. I will try to do that. I will try to show the distinguished features of GridFree. Okay. Okay. I appreciate so much for your watching. See you next time.